Hello there, welcome to CPVNet's video series on sorting algorithms, and in this video we'll see the selection sort algorithm. So let's get started. Selection sort algorithm is the very basic algorithm for sorting. Okay, there are few basic algorithms and this is one of them. So let's create an array. So as you can see, this is your array. Let's call it ARR, and these are the values like 5, 1, 3, 2, 4, and these are the index. Okay, so this is the array you want to sort with this selection sort algorithm. And wait a minute, before going for any algorithm, like you're learning selection sort algorithm right now in this video, first always ask why selection sort or why something else. Okay, so it will be really very easy for you to remember whatever you have learned, because generally what happens, you will learn, after 2 days you will forget. Okay, so I'll tell you why selection sort was called selection sort. Okay, this will help you to remember this sorting algorithm for a long time. Okay, because there are lots of algorithm like this is selection sort. There is one algorithm called bubble sort, insertion sort, quick sort, merge sort, and radix sort and bucket sort. Lots of sorting algorithms are there. So if you will remember by their name, it will be easier for you, and try to match the name with the functionality. So selection sort is named on the behavior. It will select the position, like this is your array position, right? So this is 0th position, first position, second position, and so on and so forth. So this sorting algorithm select the position and find the right candidate for this position. So this is the 0th position, and if you are looking for the right candidate, this one is the right candidate if we are sorting it ascending order. So what is ascending order? Ascending order is like 1, 2, 3, and 4, and descending order is 4, 3, 2, 1. Both are sorted. Okay, but this is in increasing order and this one is in decreasing order. Okay, so this is called ascending and this is called descending order. So here we'll be looking for ascending, like 1, 2, 3, 4. Okay, so if we are looking for ascending, the correct candidate for this location, 0th location, is 1. Okay, so as we will start implementing this selection sort, this 1 will automatically come at this position, and then we'll move our cursor from here to here, and then we will look for the right candidate for this place. Okay, for first place, and then this 2 will come here, and then we'll move our cursor from here to here, and we'll search the right candidate for this location, which is 3 itself. So this is not going to move, and like this we'll move here, then 4 will come here, and like this, and then 5th will be there automatically. I don't know, let's see how this whole thing will work. So let's rewrite this again and start the calculation. 5, 1, 3, 2, 4, and position is 0, 1, 2, 3, and 4. So this is your array position, this is your array value. Now as I told that we will be starting from first location here, so in order to perform all the operations, we need one data structure. I need a variable which will keep track of the minimum value index. Okay, so let's call this min id. Okay, and this is one variable. So the rule is like this: you will start with the 0 position. Whenever you start, you initialize this value to this minimum id. So for now it is 0. Okay, now you will compare 0th location with first location. Okay, and wait, let me explain the use of this minimum id variable here. Okay, so as I told, you will be selecting one position. So in this case you are selecting the 0th position in array. So it is quite obvious that you will be looking for the right candidate. Maybe you are having the right candidate, but in this case it is 5, so it is not the right candidate. So this is the right candidate. So how you will search? So you will be comparing this position with the rest of the positions. No, that is not true. Okay, so pay attention what I'm telling right now. How you will compare? You want the minimum value among all these values. So what you will do? you will initialize this minimum ID with whatever you are starting with. So you are starting with 0, so you will initialize with 0. Now you will compare this minimum ID, which is the location of your array, with rest of the locations. And if you encounter any location which is holding lesser value like this one, then you will update yourself. Okay, so as we can see, we have initialized this 0 here. Now we'll compare this one with 1. So 1 is having 1 as value and 0 is having 5. So we'll compare these two, and our minimum ID should have the lesser value index. But here in this case, the lesser value index is this 1. Okay, not 0. This 0 is holding greater value than 1 index. So we'll update the index. It means we have found that there is another index in array which is minimum. Okay, so now we will compare this one with this one, and if this is happen to be minimum, we will update this 2 here instead of 1. But that is not the case here, because this 1 is only the minimum. So if you will compare every variable, you will end up having this only. Okay, so this is how we keep the track of minimum value in search. It is really very simple. You initialize whatever you are starting with here, like 0 we initialize initially. Then you compare this location with rest of the locations. If these locations are holding lesser value than this location, then just update this place with this location and then search consecutively. We'll see how this whole thing will work. Let me clear all this mess, and we'll see when we'll go through the sorting process. Okay, so you're comparing these two values. Now 5 is greater than 1, and this is not the proper order. Okay, 5 should be in the right hand side of this 1 if you want ascending order. So we got the next minimum index, which is this 1. So we will remove this 0, we will keep this 1. Okay, now you will compare this index with the next one, I mean this second one, okay, which is 3. So this 1 is less than 3, and this is the perfect position. Okay, so we will not change this location. Now we will check with this 3. 1 is less than 2, that is also okay, and then we'll go for this one. Okay, 1 is less than 4, that is also fine. Okay, so did you see that we have completed our whole search for this particular location? Okay, and we end up having this 1 at this variable. Got it? Now as you started this whole search for this first position, you will swap yourself, I mean this first position, with the position you got in this minimum ID variable. Okay, so this is 1, and don't forget, this is an index, this is not the value. Okay, let me write this. This is an index. So 0th index value and first index value will got interchanged. Okay, so this was first pass, we call it pass. So in first pass, the result is like 1, 5, 3, 2, and 4, and the locations are, so we have interchanged the value here. And did you notice this 0th position is having its correct value 1? Okay, so this is going to be your second pass, and you are done with this much of the array. This you need to sort, but this is already sorted. So 0th location is holding the correct candidate for its location. That's why this is called selection sort. You selected the position which happened to be 0 here, and you find the correct value for that. And this might be a little confusing for the beginners, and if you are confused, don't worry, we'll be sorting these values and you will understand how this whole thing is working. Okay, so as this is sorted, we will search for the next location. Okay, so this is our starting location, and as I told, when you start, you initialize the index to this one. Okay, so I will just remove this. So initially we started with this 0th location, so we had placed 0 here. Now we are starting with this first position, so we'll place this 1 here. Now whatever we placed at this location, we will compare with the next one. Okay, so next one is this one, 2. So we will compare these two things. So 3 is less than 5, and this is not the proper order. So minimum ID would become now 2 here. Okay, instead of this 1, we will assign this 2 here. And now we'll search the next one. So next one is this 3 with second. Okay, so these two will be compared, 3 and 2. And this is also not the proper order because 3 is greater than 2. So we get next ID, which is minimum. So we will remove this one and we'll update here. Okay, so now we'll compare this 3 with 4. So 3 means this is index, don't forget. So third value with fourth value. So 2 is less than 4. Yes, it is true. So we will not update this because at third location 2 is the minimum one. Okay, and we don't have any values to compare further. We'll stop here. And whatever is there here, we will swap what we started with. Okay, so we started with this first and we are having 3 here. So first value will get swapped with third value. Okay, so this 5 will come here and this 2 will go here. So we'll see how this whole thing will look. So as I told, this is already sorted. 1 holding 0th location. First, this 2 will come here and 5 will go here. Okay, so 2, 3, 4 and 3, 5, 4. So this is value part, this is index part. So we have sorted out this much now. Okay, so like this we'll move further. So this is your third pass, and now you will start from here. So you will search for the right candidate for this location. Okay, and we can see the right candidate is this 3 itself. So you will see that this is not gonna change. Okay, so what I told, that whenever you start with, you will update that value here. Okay, so let me remove all these things. So now ID is 2 because you're starting with 2 here. Now you'll be comparing this with ID 3. So is this proper order? Like 3 is less than 5? Yes, 3 is less than 5 and 3 is coming before 5. So that is also a proper order. We won't change this location. We will go to next ID, which is this fourth. So 3 is less than 4. Yes, it is less than 4. So this is also a correct order, and we don't have any further values. So we'll stop here. And what we do, we change this location with this location, and both are same. So second ID will go to itself, which is nothing but 3 here. So we are not changing anything. It will look like this. In fourth pass, this would look like again the similar one. 1, 2, 3, 5 and 4, and this 0, 1, 2, 3, 4. So again, this is index, this is value. Okay, so we have sorted out this much locations. Now we will start with this. So as I told, if we are starting, we will update this variable here. Okay, so update this with location 3. Now you are having this 3 here, which you will compare with this next one. Is this proper order? No, this is not proper order. 4 should be here and 5 should be here. Then only it is proper order. But this is not proper order. So you will update 4 here. Okay, 4. And then you will go and search for next value, which is not there. It means your array is finished. And what we do when we are done with the search, we replace this index value with this index value. Okay, so in short, we'll swap these two values, and this is going to look like this: 1, 2, 3, which was already sorted, 0, 1, 2, and then 4 will come here, 5 will go here. So 4 and 5, and index will be 3 and 4. Okay, so as you can see, this is a sorted array. If you got confused, I will show you the program that will clear your doubt. Okay, and this is your program here. This is the main function. Here we are creating this array and want to sort this. Okay, and calling this select sort. This is the function. We are getting the array here and the size of the array. Okay, I will go from 0 to n minus 1 and j will go I plus 1 to n. Okay, so you have passed this array here. We have reached to this for loop when I is equal to 0 to n minus 1. So n is 5 here, so this would be 4. Okay, so I less than 4. Then we'll go inside. Minimum ID will be assigned with I. So this is what I was telling you, like whenever you start, you initialize your minimum ID with that value. I mean the index value. So initially, if you remember, you initialized this 0 here whenever you started this, then you initialized with 1, then 2, then 3, like that. So this minimum ID is 0 for now, okay, because this I is equal to 0. Okay, so this minimum ID is also 0 here. This j is equal to 0 plus 1. In that case, it is 1. Okay, and 1 is less than n. N is 5 here, so this is true. And you will go inside this array of jth position. J is 1. So 1 is this position. And if this is less than this one, I mean this minimum ID is 0 position and this j is 1. So 0th position value is greater than 1 position, then assign this minimum ID is equal to j. So j is 1 now, so we will assign this minimum ID will become 1 now. Okay, because this value is getting true. Array of j, which is 1, is less than array of minimum ID, which is 0. So 5 is greater than 1, which is true. So that's why we have made it 1. Okay, this 0 will go off. Now it is 1. Then loop will go back and j plus plus. So j was 1, then it will become 2. Then we'll again come back and check here. Array second position is less than array's minimum ID position, and minimum ID is 1. So first location will be compared to second location. So this will be compared with this one. So is this greater than this? No, it is not. So we will not go inside and minimum ID will not change. Then j plus plus, then j will become 3 here. Then we'll again compare this 3 with 1. Is this greater than this? No. Then we will not change. Then j will become 4 here. And 4 is less than n, n is 5, so this is true, and we'll come to this position. We'll again check minimum ID, which is 1, don't forget, is greater than this. No, it is not, so it will not come inside this. J will become 5 now, and 5 is less than 5. This condition is false. This whole loop will break. We will come out. There is this swap function outside. Then remember, your minimum ID is having 1, so we will change that minimum ID position with array of I position, and I is having 0th location. So 0th location, which is this one, will get swapped with location 1 here, which is this one. And that's what we did initially when we change all these two. Okay, so once you swapped it, this is the function for swapping. Two values will come, you will interchange the values, and you will come back here. And this is the outer for loop. You will go back here, I will get incremented, then I will become 1. Okay, now let's remove everything here. It will be easier for us to understand this. So I is 1 now. So what we did, we will initialize 1 to this minimum ID. So this will become 1. So we are in second pass now. Okay, so once this inner for loop is over, your first pass is over. Okay, then now you are in second pass. So this is the result of your first pass. Your 1 has come to the correct location, which is this 0th location. Okay, and as I told, whenever you start, you initialize the starting index to this minimum ID, and that's what we are doing here. Okay, now j will be I plus 1, so I is 1, so j will be 2, and 2 is less than 5, which is true. We'll go inside, j is 2 and minimum ID is 1, so we will compare this one with this one. Is this greater than this? Yes, it is true. Then minimum ID is equal to j will execute, and this will become 2 now. and we'll go back here. J will get incremented, J will become 3. We'll come back here. Now J is 3. So we'll be comparing this location with minimum ID, which is 2 now, with this location. So 3 is greater than 2. Yes, it is true. So we'll again change it. Then minimum ID will become 3 now. Okay? Here, because of this statement. And then we'll go back. J will get incremented. J will become 4 now. Then array of J, which is 4, will compare with array of minimum ID. Minimum ID is 3 now. So this 3 and 4 will get compared. Is this value greater than this value? No, it is not. So we will not go inside this if statement. We'll again go back here and J will get incremented. J will become 5. And 5 is less than n, which is 5. This is not true. Then this inner loop will again break. You will hit this swap function now, and then you will swap this minimum ID with I. So what is this I now? I is 1 and minimum ID is 3. See, and I is 1. So 1 will be interchanged with third location. So this 1 is going to get interchanged with third location. So 2 will go here and 5 will come here. Okay, that's what happened here. Got it? And we'll come out from that swapping. Then we'll go back I++. I will become 2. Then we are pointing at this location, second location. Okay, and this much is already sorted. Don't miss this. So let's run for this as well. I will clear out some mess. So I is 2 now. Pointing at this location will come inside. Minimum ID will become 2. This will become 3. 3 is less than 5. Yes, it is. Okay, it will go inside this loop. Now you will compare array of J, which is 3, will be compared with array of minimum ID, which is 2. So this 2 will be compared with 3. So is this 3 is greater than 5? No, it is not. So we'll not go inside. We'll again go back and J++. J will become 4. 4 is less than 5. N. It is true. We'll go inside this if. We'll check if array of J, which is 4, is less than array of minimum ID. So is this 4? This value is less than this value? No, it is not. So we'll not go inside this. And we'll go back again, J++. This will become 5. 5 less than 5, false. So once this loop is false, it will get terminated. We'll hit this swap function after that. And we will change minimum ID with array of I. So minimum ID is 2 and array I is also, I is also 2. So we will end up swapping 2 with 2. So this is an extra swapping which should not happen. So in that case, you should put this swap function inside some if statement like minimum ID is not equal to I. Minimum ID not equal to I, then only you perform that. Okay, in our case it will be like 2 not equal to 2, which is false, so we will not call this swap in that case. Okay, so we'll save one extra swapping, and this is how this whole compilation running will go. And at the last you will have 3 for this I, and wait, let me clear this mess, and 3 will be here. This will become 4. 4 is less than 5. Yes, it is true. So array of 4 is less than array of 3. Let's check that. So this is array of 3 is greater than array of 4. Yes, it is true. So minimum ID will become J. J is 4. So this will become 4 now. And you will go back J++. It will become 5. 5 less than n, which is already a 5. This is false. So you will terminate this loop. You will come outside, you will hit this minimum ID is not equal to I. So our minimum ID is 4 and I is 3. Okay, so both are not equal. That's why we will swap it. So third location will get swapped with fourth location. So this third location will get swapped with 4. So 5 will come here, 4 will go here, and this much was sorted. So 1, 2, 3 was already sorted. 5 will go here and 4 will come here. So at last you end up sorting your array, and after that you will go back here I++. I will become 4, and don't miss this, I is going to get compared with I less than 4, which is false. So you will come out from this outer loop and you are done. So this is your sorted array. So now let's talk about the time complexity part of this selection sort algorithm here. Now, how to calculate the time complexity? Time complexity comes with the 4 loops. Okay, so this is one for loop and this is another for loop. And why I'm telling that, because for loop will always give you the time like this, n minus 1 here and n, because the rest of the things like this one will execute only one time whenever you will call this function. Okay, so this variable creation is happening one time, but these things are happening some number of times. So let's calculate that how many times. So this particular location, I mean this one, will be executed n minus 1 time. Okay, and this for loop, so let's call this as some constant, let's suppose c1, and this for loop will go from I plus 1 to n. So this is not always the constant, like it will run these many times only. So this is like for I is equal to 0, for first case this will go up to 1 to n. So it will go n minus 1 time for I is equal to 0, and then for I is equal to 1 it will go n minus 2 times. Okay, so for I is equal to 2 it will go n minus 3 times, because you are adding this 1. If I is 1, 1 plus 1 2, 2 less than n, so it is going that many times. So if you will notice this, this is nothing but n into n minus 1 divided by 2. So this expression, this if condition, and this is going to get executed roughly these many times. Okay, and the time which will take to execute this much, let's suppose that is c2. And then lastly, this swap function, this is going to get executed how many times? N minus 1 time. So this is, let's suppose, constant c3, and this is also going to execute n minus 1 time. So let's write it in one line here. So this is n minus 1 time c1, so n minus 1 times c1, because this is going to get executed n minus 1 time, and this one, so plus n into n minus 1 divided by 2, and the constant for this is c2, and this one is plus n minus 1 times c3. So this is your expression here. So if you solve this expression, this n is going to multiply with this one, and this is going to produce n square. Okay, so the complexity of this one is going to be bigger of n square. We always choose the higher order term, because there will be lots of n and there will be lots of constant values, so you neglect all those constant things. We go for the higher value, I mean order, so that is n square. So at max this will go n square time. Okay, so this is the final time complexity for this one. I hope you enjoyed the video. If you like the video, don't forget to hit the like button, and if you haven't subscribed yet, go for it. I'll be bringing so many videos like this. I'll see you in the next video. Bye bye.